So, friends, welcome to this lecture series of geomorphology, and today we will talk about this exploration geomorphology, in particular the oil and gas exploration. You see, exploration geomorphology is nothing, it is like exploration geomorphology. It is the experience we received or we gained from this various geomorphic environment like fluvial, glacial, aeolian, coastal. So, those geomorphic experience we will use in exploration, because particular geomorphic environment is also it is particular due to depositional environment it is corresponding with. So, that is why in particular for example, we are talking about a fluvial environment. Talking from this head of this river up to this mouth, we have the erosional zone, we have depositional zone, we have transportation zone. So, similarly, in this fluvial environment, in particularly the deltaic regions in the flood plain, we developed sand bodies, and sand bodies are developed with the clays, alternative clays. Similarly, in deltas we have sand, clays, silt like that. So, that they are very good source for petroleum hydrocarbon generation as well as preservation. Similarly, if we talk about this mineral exploration, similarly mineral exploration, there is nothing like a mineral exploration geomorphology, but this geomorphic environment or this geomorphic, that means the topography, different topographic controls, how they behave in exploration, that is the exploration geomorphology. For example, suppose we are talking about this coastal environment. Coastal environment we have already discussed, there are good examples of heavy mineral deposits in the east coast of India, though that means our this geomorphic experience, that means there is a break, there is eastern ghat, there is a close to coast, and continuously wave action is there. So, that the fine material or the lighter material is removed and the heavier material they are concentrated. So, that is why we are getting some heavy mineral deposit like in Gopalpur in Kerala, some heavy mineral deposits are there. Similarly, at the mountain fronts we have alluvial, we have diluvial and landforms. So, we have creeps. So, in that creeps we are getting some heavies they are deposited are there. Similarly, in the river, at this river meanders we have some heavy mineral deposits, and like that. See, mineral exploration, oil and gas exploration. So, everywhere our geomorphic knowledge is very much useful to define what type of mineral or what type of wealth we are looking for. So, that what type of geomorphic environment we should target for that. And today we are going to discuss elaborately about this exploration geomorphology in special reference to oil field. So, why that is important? What does it mean, this oil field geomorphology? Generally, if you see oil and gas, they mostly 99% of petroleum hydrocarbon PHC, it refers to petroleum hydrocarbon. It is found in sedimentary rock. So far we have whatever our exploration information, so we have. So that means 99% of this petroleum hydrocarbon they remains in the sedimentary rock. So that means this sedimentary rock, this formation environment, the geomorphic environment which is responsible for formation of those sedimentary rocks, they are important rather than every geomorphic environment. So that means in this class we will concentrate very particularly in those type of sedimentary environment, sedimentary that geomorphic environment which leads to deposition of a particular type of sedimentary rock which are suitable for generation as well as preservation of petroleum hydrocarbon in that. In particularly here, if you see within that sedimentary rock, the sandstone it contains 72% of this petroleum hydrocarbon, limestone it is 22 to 25% and other 2 to 3%. So, here we are talking about the reservoir, not talking about the formation. Sandstone is a very good reservoir rock, not a source rock. Similarly, limestone may be a source rock, may be reservoir rock, depends upon its organic content so far. And others they are 2 to 3%, like somewhere it is fractured basalt is there, somewhere it is fractured granite is there, fractured shale we are nowadays we are exploring shale gas. So, it is shale, it is a source as well as as a reservoir rock also. So, that means particularly when we are talking something about the oil and gas, so far we have whatever the information we have, it says the sandstone contains 72% of this petroleum hydrocarbon. So, that is why accumulation of oil and gas in a sandstone body depends upon several factors. Sandstone body we are emphasizing here in this class, because the sandstone that forms in particular geomorphic environment, starting from this aeolian environment through coastal environment to fluvial environment. So, that means it is a broad geomorphic environments are there, different geomorphic environments which led to the deposition of sandstone. That is why sandstone is very much important in terms of petroleum hydrocarbon exploration is concerned. So, accumulation of oil and gas in a sandstone body depends upon several factors. What are those factors? One is stages of petroleum hydrocarbon generation. Stages of petroleum hydrocarbon generation means in petroleum hydrocarbon generation we have different stages like the diagenetic stage, catagenic stage, metagenic stage, metamorphic stage. In the diagenetic stage we do not have much petroleum, very less amount. The catagenetic stage and metagenetic stage we generally we get maximum petroleum hydrocarbon in these two stages. So, at which stage the petroleum or the organic matter has matured, that depends upon how much petroleum it will yield. Similarly, time of migration of hydrocarbon, time of migration means what is how much time it is taken for migrating. Either it is less time, that means it is all the petroleum hydrocarbon already migrated. If it is more time, that means in the sandstone body different part we will get petroleum hydrocarbon. Then directional deviation in porosity and permeability, this is a very important factor. Porosity, permeability, it is very porosity is required to store the petroleum hydrocarbon and permeability is required to transmit. So, until unless a sandstone is porous and permeable, we do not get petroleum hydrocarbon in it. So, existence of stratigraphic and structural closures with a suitable seal. Stratigraphic and structural closure, as we know there are two types of trap. One is stratigraphic trap, that means I am talking about the prominent tracks. One is stratigraphic trap, another is structural closure or structural trap. Within that we are getting some, that means we are getting petroleum hydrocarbons. Then geometry of the sandstone body, this means either it is a very thin or it is a thick body, it is a long elongated body, it is a pool shaped body, it is a sheet type of body. Then what type of this sandstone body looks like or it appears to, that also depends upon how much petroleum hydrocarbon it is contained, because a small body it will only accumulate a small amount, it will only store a small amount of petroleum hydrocarbon. A large elongated body it will contain more petroleum hydrocarbon. Similarly, a sheet type of body it will again contain more petroleum hydrocarbon. So, that means these factors that influence this petroleum hydrocarbon in the sandstone body. Now, if we going depth wise, the petroleum hydrocarbon occurrence less than 1500 meter we are getting 35%, 15 to 4000 meter we are getting 50%, more than 4000 meter we are getting 50%. So, that means here maximum occurrence of petroleum hydrocarbon it's between 1500 to 4000 meter depth. Similarly, in India commercial occurrence of petroleum hydrocarbon it is found between 1000 to 4500 meter depth. Similarly, as we few minutes back we are talking something about the trap, you know in this petroleum geology there are structural trap, stratigraphic trap and combination of other traps, unconformated trap and other traps also, that means structural and stratigraphy may be combined together. So, here the structural trap it is more important because it contains maximum petroleum, that is 70 to 72% of petroleum hydrocarbon forms from the structural trap. So, occurrence of petroleum based on the geological environment. Geological environment means it is a marine environment or non-marine environment. Non-marine environment means it is a fluvial environment, lacustrine environment, it is aeolian environment, it is a glacial environment. So, that means you see 90% of this petroleum it is coming from the marine environment and 10% is fluvial environment and lacustrine environment. So, that means, so here you can say these geomorphic processes which are acting in the marine, that means marine geomorphology, are this coastal geomorphology and near coast geomorphology, where because we are talking about the sandstone. Sandstone is a near coast product or a shallow water product, at the periphery basin periphery product. So, that means near coast product, marine environment, they are more prone to generate or more prone to store or more prone to generate those type of sandstone body, they are more prone to deposit those type of sandstone body, which are very much suitable for this accumulation of petroleum hydrocarbon. That does not mean other sandstone body that do not contain petroleum hydrocarbon. We have fluvial environment, we have fluvial sandstones, we have lacustrine sandstone that do contain petroleum hydrocarbon too. That is why it is a range of geomorphic process starting from the fluvial, more emphasized on the marine or the coastal process, and other processes also, they are very much responsible for generation of such type of sandstone bodies which are more prone to contain petroleum hydrocarbon in a commercial occurrence manner. So, occurs petroleum within the basin position, that the rim part, it is, if you see here, this is the rim part, it is contains 3%, shelf part it is 20%, then if the hinge part it is 67%, so deeper part it is 10%. So, that means within the marine environment, if you see restrict, this part it is contain maximum petroleum hydrocarbon. That means we are very much concerned about those sandstone bodies which are formed in these zones of or the hinge zone of a marine environment, they are more prone to hold petroleum hydrocarbon within that. So, that is why these geomorphic processes which are working particularly in these environment, they are more important as compared to other part. That does not mean other part that do not contain petroleum hydrocarbon. For example, we have fluvial environment, we have point bar deposits. In deltaic deposit, near coast sand sheet type of deposit. In the river Anastomozine river, in braided river system, we have show string sand type deposit. They do contain petroleum hydrocarbon too. So, that is why a range of geomorphic environment we are going to discuss here, and which are prone to generate sandstone body, and in turn which will accumulate petroleum hydrocarbon of a commercial quantity. So, the chances of getting more petroleum hydrocarbon, if we summarize here all this depth, this geological age, this marine environment or this depositional environment, the depth wise. So, everything if we summarize here, the more chances of getting petroleum hydrocarbon in marine environment. So, environment wise, as we concluded, marine is the most suitable one. Then lithology wise, it is sandstone, and it is Cretaceous age wise, it is the Cretaceous time which was deposited. The depth of 1500 to 4000 meter depth constant is there, and shelf and hinge area in environment wise. So, in a one sentence, if we summarize this occurrence of petroleum hydrocarbon worldwide in sandstone body, so the chances of getting more petroleum hydrocarbon in marine environment, sandstone lithology of Cretaceous age, the depth of about 4000 to 1.5 1500 meter, shelf and hinge area. So, this the key of this petroleum hydrocarbon occurrence. So, this line summarizes all types of lithology, age, depth, environment, all that summarizes here in the one line. The spatial relationship of depositional trend and geometry of permeable zone within the sandstone body are commonly unknown, because if you see, when we are talking about the sandstone body, either it is a deltaic environment or it is in a near coast environment or it is a fluvial environment, we do not know in a sandstone body in which direction the porosity is increasing or permeability is increasing or decreasing. So, that is why it is more and more information we will get with more experience and exploration. So, if you are very thorough in this geomorphic processes, we know there is a deltaic. So, for example, we are taking a deltaic process in a deltaic sandstone which is deposited in deltaic environment. We know this delta is a transition between the fluvial environment and the marine environment. So, there will be influence of both fluvial system as well as marine system. So, we are getting a sandstone body, and within sandstone body, depending upon its depositional trend, depending upon this depositional processes involved, this porosity will be change in a particular direction, the permeability will change in a particular direction. That is why we need to that means we need to clarify ourselves which direction or which particular direction or which regions in a particular sandstone body which are more porous and more permeable, because we are very much interested in petroleum hydrocarbon exploration, and petroleum hydrocarbon exploration, that means we will be interested in those areas which are more porous and permeable, because they can hold more amount of petroleum and that can yield also more amount of petroleum hydrocarbon easily, because its permeability is more. So, that means getting a sandstone body is not enough that we are getting petroleum hydrocarbon. Suppose everything is satisfied that we are getting a Cretaceous age sandstone body of 1500 to 4000 meter deposited in hinge zone area. So, that is not enough. So, the enough is within that sandstone body we have to restrict ourselves, we have to bracket ourselves on which direction, on which part it is more porous and more permeable, and more thickness which part is more, because more thickness is there, because it depends upon the geometry. So, more thicker the sandstone, more amount of accumulation petroleum hydrocarbon. So, that means getting a sandstone body is not enough. Within the sandstone body we have to find out where is the more thickness is there, where more porosity and permeability is there. It may possible within a sandstone body there are number of patches which are more prone to generate petroleum hydrocarbon more easily as compared to other part, as shown in this figure. If you see here, this is a sandstone body of some area here, it is Alaska, north slope of America. It is a isopermeability map of this braided channel complex in the shade limestone formation. It is in this area. If you see here, these are this isopermeability. So, that means here these contours they are looking about the isopermeability, that means 500 millidarcy, that 300 millidarcy, that 315. That means if you see, though we are getting this area is a sandstone body, it is a whole sandstone body, within that here we are getting maximum permeability. Here that means up to here we are getting 300 permeability or like that. So, that means within the whole sandstone body, all this whole body or the entire body is not suitable for us. So, we are mainly concentrate ourselves in these areas or this part of the sandstone body which is more porous and more permeable, so that there is expectation that it might contain more petroleum hydrocarbon and it can yield petroleum hydrocarbon very easily if we drill a hole there. So, that means simply getting a sandstone body or sandstone geometry is not enough, it is the some additional or the additional and more important information we require about the sandstone body, with its thickness, its porosity distribution, its permeability distribution within that sandstone body. Sand body geometry has been classified by Pettyjohn and Potter and Seaver in 1972, and it is still we are adopting or we are following these classifications. So, if you see here, there are the 5 types of sedimentary these sandstone bodies here. One is sheet type, another is pod, ribbon, dendroid and belt. So, if you see here these sandstone bodies, their geometry is different, the thickness is different, and their depositional environment is different, and in turn it is a geomorphic processes involved for the formation of the sandstone body is different. So, that means different geomorphic environment may deposit same type of sandstone body, and same type of geomorphic environment may create different types of sandstone body. For example, if you see here sheet type of deposit, sheet it can be formed in the alluvial fans, sheet it can form at this marine environment like near coast, in the deltas, in the flood plains, in this due to migration, continuous migration of this point bar. So, that means geometry is one, that is sheet type, but we are getting in different geomorphic environment, different geological depositional environments. So, that means all this geomorphic environment we have they are important for us, that is marine environment, deltaic environment, flood plains, that is migration of these point bars, alluvial fans, all those geomorphology we should be clear about how the geomorphic process work, how the geomorphic process is changed within that geomorphic environment, so that this type of sandstone body it can generate. Similarly, pod is a small one, as the figure says, is a small and isolated one. Ribbons means elongated, like that is ribbon that we use for that these students or girls that use, and dendroid means like dendrite, they are branching out. Belt, it is coalescence of more dendroid. So, that means these type of sandstone bodies, they are particular or some combination of some geomorphic environment. So, if we have experience about the different geomorphic environments, then we can predict that this type of geomorphic environment it is there, and we are expecting this type of sandstone body. So, that our exploration strategy will be defined depending upon our experience. Talking about a sheet or blanket type, if you see a sheet or blanket mappable sandstone body may be lack of continuity and homogeneity. At one locality it may present a single sandstone body, and at other it may consist of more than one sandstone bed having individual depositional trend, shapes and petrophysical characteristics. So, example here, that means geometry is one, depositional structure is one, but geomorphic processes are different. For example, as we are just discussing, a sheet may be formed in different geological environment. So, the one locality it may present a single sandstone body, and at other it may consist of more sandstone beds. For example, suppose we are talking about the sand sheet type of deposit in the near coast. In the near coast, we have at the coastal environment we are getting sandstone body parallel to the coast, the whole coast is ranging one, it is connecting with a sandstone body, but in between when there is rivers which is cross cutting this coast. So, that means there is a discontinuity among the sandstone bodies. So, that though it is a single sandstone body, but it is divided due to this reverse perturbations. So, that means one environment, but different sandstone body, disconnected sandstone bodies. Similarly, suppose in a flood plain we generally deposit sand and silt, clay are also deposited during flood time. So, that means we are getting a blanket type sandstone body. Suppose river migrates, a river cross cuts its own deposit. So, that means a sandstone body will be dissected into different parts, different segments. So, that means it represent either it may represent a single sandstone body, or it may more than one sandstone body, but individual depositional trend. Individual depositional trend means, suppose we are talking about the sandstone body formed in the alluvial fans. In the alluvial fans, generally river migrate continuously, because due to the sediment load, more sediment load, the river channel has to accommodate itself. So, now suppose for the formation of the sandstone body in a alluvial fan, this is the position at the present condition, this is the position of the alluvial fan, we are getting a sand body here. So, once the river migrates here, that means the sand body trend will be changed. So, that means earlier the sand sheet was deposited here strike wise, and now it will change like this. So, that means a single sandstone body may form in different depositional process, and the trend of the sandstone body that depends upon the geomorphic processes and these geomorphic agents which are involved in their formation. At particular location, oil may be encountered in sandstone where it occurs below the off dip edge, but not in the adjacent sandstone that pinches out elsewhere. So, it is possible that if you are getting oil and gas in one sandstone body, it is not necessarily this sandstone adjacent to it also contains petroleum hydrocarbon. That depends upon the geomorphic environment. So, for example, here suppose a particular location oil and gas may be encountered in the sandstone body, but it occurs below the updip region. So, for example, here if you see this is the updip and this is the sandstone body, this is the reservoir rock, and we are getting gas here, oil here and water here. So, that means here we are containing petroleum hydrocarbon, but other sandstone bodies, suppose for example, it is here just close to it, but it is pinches out somewhere there here. So, that means here we may not get petroleum hydrocarbon. Petroleum hydrocarbon, if it is there, we may get somewhere here. So, that means it says, so at a particular location oil may be encountered in sandstone where it occurs below the updip edge, but not in the adjacent sandstone that pinches out somewhere else. If it is pinching out somewhere else, so there may be good chance that getting petroleum in the other part rather than adjacent to this system, adjacent to this present sandstone body. So, sheet like stratigraphic unit consists of essentially of sandstone may be originated as transgressive or regressive shoreline sand. Transgressive, regressive shoreline sand, for example, here shoreline regression, shoreline transgression. What is transgression and regression? It is the coastal encroachment of sea is transgression and this retreat of sea is called regression. So, it is sea level rise and transgression regression are different thing, sea level rise and fall are different thing. In a particular case sea level may rise, but there may be regression, that depends upon this sediment supply, depends upon coastal upliftment and subsidence. If for example, sea level is rising, but the coast is uplifting at a higher rate. So, that means though sea level rising, but there will be sea level, there will be regression rather than transgression. Similarly, if it is sea level is falling, but coast is subsiding at a higher rate as compared to the sea level fall. So, there will be transgression. So, that means sea level rise and fall and marine transgression regressions are two different things. So, one is transgressive or regressive shoreline sand. During transgression, the rivers has to restrict their deposit. During regression, the rivers they can migrate deep into the sea. So, in either of this case, we are getting sandstone bodies. Then as widespread sandbed within coalescence alluvial fans. Coalescence alluvial fans we know in a geomorphic environment when we are talking about fluvial geomorphology, that is called bajada. When two or more alluvial fans they are meeting or coalescence, this geological structure is called bajada. So, that means here is a alluvial fan and here is a alluvial fan, that means here is a sand sheet and here is a sand sheet, and once they are coalescence each other. So, that means we are getting a sheet type of deposit. Is braided and laterally migrating estuarine deposit. Laterally migrating estuarines. Laterally migrate, that means that depends upon the sea and this river interface, this interaction. So, if it laterally migrates, the braided channels they are migrating laterally. This that is estuarine deposit, this is migrating laterally. So, in either of these cases we may get a sheet type of deposit of sand body. As rivers migrate on a broad plain. So, if you see here, this is the flood plain of a river and river is migrating. So, its river is migrating along this plain, that means sand body, one sand body was, suppose river was here, the sand was deposited somewhere here and somewhere here. Similarly, river is migrating this way for example, or this way for example. So, here we will get another sand body, here we will get another sand body. So, with time these sand bodies of different generations, I am talking about the sand bodies of different generations, they will coalescence with each other and finally forming a sheet type of deposit, but age is different. So, that means the different type of environment they can create sand bodies of a similar type of different age. As layer of sand swept out on abyssal plain of this ocean, for example, here this most part of the sands they are deposited up to here, but due to turbidity current, due to submarine landslide, suppose the sand body here it is disturbed and the sand migrates downward. So, it will be distributed in the abyssal plains. So, that means a layer of sand swept out on abyssal plains of this oceans. So, we are creating a sand sheet type deposit. So, that means starting from this landslides or this turbidity current, this river migration at these different stages, and this transgressive regressive shoreline and changes and alluvial fans. So, all those different environments, they are creating a sand body of similar type, that is of sheet type of deposit. So, in fluvial environment, this is common, like for example, if you talking about, we are talking about the migration of these point bars. The point bars, coarser grain deposits are here, then this side is cross bedded deposit, and the upper part it is parallel deposits. So, if it is migrating this way, so that means here you see it is migrating, the river is migrating in this way. Earlier here was the sandstone body, then a sandstone added to it, then a sandstone added to it, and finally, we are getting a sheet type of deposit. So, sand bodies have length width ratio approximately 1:1, may cover the few thousands of square kilometers, or these have been called as sand sheet or blanket. And elongated sand bodies on the other hand are those in the long dimensions, notably exceeding width and are 1/3 of this dimension, that is pod, ribbons and dendroids. Pod, if you see, it is length width ratio are 3, ribbons it is more than 10, then dendroid are commonly sinus and have branches either distributaries or tributaries. By lateral migration, coalescence revolve and dendrites may form belts, and dendritic belts becomes more common. So, if you are moving within their sandstone body, they are looking similar, but they can be distinguished based on their internal structure, their stratigraphic relationship, their internal structure, this fossil content, their grain size. Based on that, then the degree of compaction. So, by looking those, that the sand bodies can be distinguished, though they are look similar sand sheet, irrespective of the origin, they look like, but they can be distinguished which environment they are formed, either it is a coalescence of alluvial fan, or it is deltas, or it is coastal plains, or it is migration of this point bars. All these sandstone bodies that can be distinguished. Similarly, offlap, onlap, as we have already discussed, which migration of coast or this migration of shoreline, that creates offlap and onlap, that also create this sand sheet type of deposit. Similarly, sometimes it is difficult to distinguish, but as we have discussed, based on the grain gradient, based on the geophysical log, sedimentary structure and fossil content, these sandstone bodies can be distinguished. And it may be, sandstone body may be product of erosion, that is the erosional inlayers if you are getting here. Similarly, in the sandstone sands formed in the costas, they can form the sandstone bodies like that. And similarly, some environment like here, this deltaic environment, this river environment, that can form some type of deposit which is ribbon type or this dendrite type deposit. So, nevertheless, their geometry of sedimentary accumulation is known, the geometry of depositional trend, the sandstone body content within the depositional environment can be inferred. So, we should have thorough knowledge about how this sandstone was deposited, which geomorphic environment was responsible for it. So, if we have thorough knowledge about this, we can create a working basis which with the test the variability of various interpretation as new data comes in hand. So, that we can use, we can plan our exploration strategy, which direction our exploration goes, which direction we go for drilling, which place of this environment we can expecting petroleum, hydrocarbon. If we have sufficient knowledge about the depositional environment, if we have sufficient knowledge about the geomorphic processes involved in this particular depositional environment, then we can find out which direction we are, our exploration work is going on. Okay. So, I think we should stop here and we will meet in the next class. Thank you.